Yeah, hi, hello, welcome back to my YouTube channel. Today I'm here to say about how I'm going to explain about like insurance database using star schema. Firstly, we'll see what is star schema and what is the major advantages and disadvantages of star schema. What is star schema? Is a fundamental data modeling technique used in database. It is characterized by central fact table and surrounded by relevant dimensional table. Let us see through Excel how we are going to use star schema. Let us take this is a central database and there are some fundamental dimension tables are surrounded with this. Some fundamental this dimensions surrounded with this and these have interconnections between every tables every tables. Like there must be at least one relationship between each and every table. So the table present this we can say this is a this is a star schema, and this is our dimension tables dimension table dimension table. This is also a dimension table. This is also a dimension table. This also a dimension table. And this is the main database of SQL because it shares the entire data and to the dimensional tables. There must be at least one between this relationship relationship between this star schema and the dimension table. It represents what's the connection between the star schema and the dimension tables of this schema. And like I think we get the basic awareness of this star schema. So let us move towards the structure. For example, let us take the example of climb. There must be a date and climb type. Firstly, I'm talking about insurance database. So there must be like agent and customer. There will be like customer, right? There are some policies, and there will be like if anyone instead of customer, it's like for example, there is a thief who is like thefting their money from the customer agent. Then we are able to use fraud detection and then payment location and claim type and data type. These are the dimension tables, and this is the main database of this star scheme. So let us think this is the main database, and these are the dimension tables. Let us think this is customer and agent, policy, money, transaction, and all. So like this star schema happens. So it is difficult to process and easy to customize the tables, and it takes less data to store. Let us see client table and what are the client factors and client identities like what are the constraints have been included in client table. There, if we see in the leftmost table, like there is a client ID, policy ID, customer ID, agent ID, claim date ID, and a claim type, a claim amount, claim status, and time to settle claim. It is a core table like of the database, like a climb table. If there is no climb table, there will be no dimension tables. Like there will be no other tables, and this is a fact table. Or we for instead of database, we are able to say this is a fact table. Firstly, we'll creating a climb ID with integer, given six numbers. It is a primary key. We have given here auto increment because like we don't need to add everything if we give it in a row like for example we can take a roll number a student in a roll number like or transactions in your phone pay or google pay, it will be increased right the time and the serial id or everything. So like this it will be auto incremented. And next policy id, it should not be null. And customer id, every customer has his own ID and agent ID. Every agent has his own ID. It should not be null. If there is no ID, then the agent is invalid. And claim date ID are not null. And claim amount, claim status. If like there are three, I have given like a three claim status like approved, rejected, and pending. If there is like claim status approved or rejected or pending, these three are the most suitable challenges for this claim testers. Like if firstly he will be approved, like the employee will approve or he can reject or he can say show this pending. And this like claim type, it should not be null, right? So if you wanna claim everything, you should say in a boolean type like accident or theft. If you see, for example, let us see for example a thief came into my uh, I lost my ATM card. A thief came to me and like he just took he just like know my ODB on or like by screen mirroring or night mirroring like he knows my ATM ID and then like we can say accident or theft in the sense of like he's withdrawing money with my account. Time to settle like how much time we are going to settle client, and that's it. There are key dimension tables like customer table, agent table, data info, and policy like a customer table, customer ID, customer name, gender, age, address, material status like it should be married and married, or employment status it should not be null, right? If he is doing only one job or two jobs, and risk profile it should be like a let us check the customer profile like if it is in race, low, medium, or high. It should be only three possible ways yeah, to check a risk profile. And in agent, there will be like agent ID, name, region, type. The type should be like independent broker or company employed. Agent should be like there. There are three types of agents. One who does for itself, like independent agents. He'll do like uh, like he'll do for himself, gathering the customers from the clients from the other roads or like he'll go to door by door. And broker who is the transmitter between the company and the customer. And company employed, he's just like an employee in a company. And data info like data ID, it is a primary key, it should not be null, right? Date ID and month, quarter, year, and year, fiscal period, like it should not be null. And policy, uh, in policy table, the primary key should be policy ID. Then data should be like policy type and coverage type and premium amount and policy start date and policy expire date. Like if you, for example, I have taken the policy. See, uh, policy, it starts on 2000, sorry, 2006 and ends ends on 2040. It should be like some dates. I should not be null. There must be a start date and end date for a policy. Policy there must be like a insurance policy and all like insurance also will see like there will be no, yeah, it should not be, yeah. And additional fact tables like what we are going to add the fact tables compared to the other websites or other companies or other banks. In insurance like we need to detect frauds like the first one should be like fraud case ID and then claim ID and then detection date like when we have detected or fraud type it like fraud type is mostly done in two types like staged accident or false documentation. Yeah, there might be a chance that customer may fill the false documentation or like he may give a false information to the company and there'll be like process. See, let us think this. There is a customer customer giving information to the company, giving information like a false information. False information. He might give an original data if we have. Otherwise, he can't. So there must be chances, right? There must be a chances. It might be the test case. Like if he might give the false information also for his uh, personal reasons or all. So the status should be like under information confirmed or clear. If status status it should be like under investigation. They might be like under investigation, or they might be completed, or it should be like not approved. There might be three chances. Like it might be they must doing investigation or confirmed or cleared. It might be like cleared in the sense completed. Premium payments. If anyone is taking a premium payments, there should be like payment ID, policy ID, and payment account, payment date ID, payment method. Let us act uh, some more additional dimension table like cloud type and region. So it should be like region is also an auto implement. It should show the region name and country and claim how he is going to be claimed. This is the start schema. This is a claim table. It contains claim ID, policy ID. Here, policy ID, customer ID, agent ID, client date ID are the foreign keys taken from the other dimension table. So let us think. There is a policy table here. The policy ID here is like a here is it is a primary key, and here it comes a foreign key. And the relation is like the policy, like how he is going to be taken, and then all. Here if we say this is a customer table, right? Customer ID is here, it is a primary key, and here in claim table it is a foreign key. And here agent table, agent ID is a primary key, and claim table it is a foreign key. And date info table, like what's the date ID, here it is a primary key, and in claim date ID it is a foreign key in claim table. And like this there are some more constraints like claim amount, claim status, claim type, and time to settle. And this should be like this must be required in this table. And in policy table, as we saw on policy type, coverage type, premium amount, and policy start date, policy expire date. And in agent table, there was like agent ID, agent name, agent region, agent type. And in customer table, there was like customer name, gender, age, address, material status, employment status, or risk profile. And date info table, there is like a date ID, date, month, quarter, and year, and the fiscal year. Business use cases, there must be like business cases in claim analysis, premium analysis, fraud detection, and agent performance. In climate analysis, like we would see how the customers are going to come and take they are claiming their own policies and all. In premium analysis, like they would take in a certain period of time, it would be done right. And in fraud detection, if as we have taken example of theft, there might be happenings of theft, uh, robbery, and all, right? So in agent performance also, like if there is a better, good, and bad, something like this. Agent performance, like how agents are doing frauds in this order, we are able to see this. And the benefits of using star schema in in this is like easy data querying and reporting, improved decision making, scalability of large data sets. Like it will be like more scalable compared to Snowflake and other schemas uh, in this in this business logistics. And suppose predictive analysis, it supports the predictive analysis also. And in conclusion, this project is focused on designing an efficient star schema model to organize and analyze complex insurance data. The schema addresses challenges in handling diverse data such as claims, policies, premiums, and agent performance. Let us see how we created the tables in MySQL. First, we have created a database and then use insurance company. Like just said that using this database, then create a table of policy, customer, agent, date info, and client. And just have added the foreign keys here, and then premium payments. I just added something date info and just inserted the for example values how it is going to be, and that's it. Like this how it is created. Thank you.